Good afternoon, everyone. I'm Jim Lake, Vice President of Training here at Viking Corporation. Today we're going to be on Tech Talks. We're going to be talking about protecting refrigerated spaces and freezer spaces. And my guest here this time around, this month, is back to Shaun Kramer again to talk about the different types of systems, the different types of sprinklers, and the different types of designs and arrangements that we use to protect these special spaces. But Shaun, to start off with, I thought we would just kind of go through what we're trying to achieve here. The ability, everybody out there, hopefully at the end of this, is going to have the ability to discuss the various types of cold storage, how they're defined and how they're protected, describe the systems that are used to protect them, and identify sprinklers and some of the specific requirements that go on with those particular sprinklers, whether they're a CMSA sprinkler or an ESFR sprinkler that's used to protect that kind of space. So the interesting thing then, again, what's important to remember here is we are protecting storage spaces. So when you're protecting storage spaces, it's all about ceiling height. It's all about storage height, storage commodity, storage arrangement. All of those things still apply. It's just that it happens to be in a refrigerated space. Not really anything different there in a warehouse, but might have some differences when we get into that, what you call a box in a box situation.
That's correct, yes.
Okay, so let's start off with then we're kind of some baseline here and what NFPA 13 says about refrigerated warehouses or freezer spaces, which not much. What it does say is that where any portion of the system is subject to freezing, then the temperature and the temperatures cannot be reliably maintained at or above 40 degrees Fahrenheit. The system that shall be installed is a dry system or a pre-action system. So limiting our choices, and for obvious reasons, we don't want water in the pipe.
Right.
Now, what's interesting is then we get into the legal definitions of some of these spaces. You get a legal definition of refrigerated warehouse, and it tracks right along with the definition or the terminology or the requirement in NFPA 13, but it sets it at 41 degrees F. So it's right in there. It's typically any place where facilities that are used to cool or keep foods, fresh and unprocessed fruits at temperatures below 41 degrees. Now, obviously it's in rack storage we've got here. So we've got probably something, I don't know, maybe 20 feet of storage right there, maybe 30-foot ceiling on racks. And so now how are we going to protect this? In a warehouse, what's our best protection? What system are we going to use here to protect these?
Well, if you have full height walls in the area that you're looking at, as we saw earlier, NFPA 13 allows a dry pipe system or a pre-action system.
Okay.
Even though a dry system is allowed, it's not really the best system for that type of application because you're dealing with very cold temperatures sometimes. And if you get a false activation of your system and you accidentally get water into that area, you can get frost plugs, ice plugs developing in the piping. And that becomes a very labor intensive process if that happens, because most of the time the owner is not going to take the cooler freezer out of service,
right,
and you still have to go in there at whatever temperature it's at, take down all his pipe, take it out of the cooler freezer, dry it out,
right,
and then reinstall it to make sure that there's no additional ice plugs in it.
Wow.
So yes, a dry system is an option, but it's really not the preferred option for this type of area. We're really looking at double interlock pre-action systems as your type of system that you're going to use.
Okay. Is there any special detection that is it advantageous in this, or is it just standard heat detection that operates the system?
Yeah, usually linear wire detection. That's one of the more common types of detections that's used in that type of application. In some occasions, you can see air aspirating detection being used in these type of areas. But yeah, by far most common would be your linear wire detection that's used.
Okay. Yeah. So all right, so we're in a refrigerated space. We're on a dry system, maybe, or we're on a double interlock pre-action system. So we're limited then in the types of sprinklers that we can use, obviously here.
Sure.
We can't use ESFR sprinklers because they're only permitted on wet systems. So you're not going to be running water in here. So what's the solution here to getting to protecting something with a lot of fuel. It's arranged in racks, so we know it's going to be a fairly challenging fire. We know that there's going to be some plastics probably in the packaging. We know that there's going to be some challenges here to this type of a fire. So how are we actually delivering? How are we going to get this to be protected? What's our best bet?
Well, the best case scenario that we'd have for that type of storage arrangement would be if it's being classified as a class 3 commodity or less, because in that case we can use our VK512 K25 K factor CMSA sprinkler.
Okay.
This allows for up to a 45-foot ceiling height using a double interlock pre-action system.
Okay.
So that would allow you to have ceiling only protection, whereas if you don't have ceiling only protection, now you got to start worrying about putting in-rack sprinklers in. And there's just a lot more potential for damage in that type of application as products being loaded and unloaded from the racks and could possibly get hit by a pallet as it's being unloaded or loaded into the rack.
Okay, so hang on.
Yep.
This allows you to avoid the K25. It's a control mode sprinkler, though. It's not a suppression mode.
Correct.
Okay, so it's not designed to put a lot of water on the fire for the express purposes of limiting the heat release rate. I mean, dramatically reducing the heat release rate, which is kind of that definition of suppression. This is still designed like every other control mode sprinkler. Put water on it, wet the area around it, and control it till we have fire department show up with big water, right? That's still the mode that we're under here.
Correct. That's the way in which it's tested.
But it doesn't require, with this design, it doesn't require in-rack sprinklers at all, or is it up to a certain height?
Well, it wouldn't require them at all, and that's part of it being a CMSA control mode specific application.
Okay.
It was tested for specific applications with ceiling only protection up to the 45 feet. So with this sprinkler, you can do ceiling only protection up to that height, but you have to meet a water delivery time.
I was going to ask you, there's got to be some restrictions on this here. So there's a water transit time that we have to calculate.
That's correct.
Okay.
So with the water delivery time, depending upon what the ceiling height is, it might be 40 seconds. So factory mutual requires 40 seconds regardless of the sprinkler, but it could be 25 seconds, or even at the highest height and commodity, it gets down to 20 seconds.
Okay.
Now that doesn't sound like a lot of time, but with a properly designed system, you're looking at about a maximum of a 15,000 square foot system, as long as you have it close to the cooler freezer that it's protecting. The thing is, you don't want to have a 400 to 600 foot run from a riser room before you even enter into the freezer,
right?
Or else you're just not going to have the transit time available to meet that 20-second water delivery time. One of the nice things about it, though, is if you use the Viking Model E1 accelerator on our double interlock pre-action system, and it typically tends to activate in 1 second or less. So now that 20-second water delivery time doesn't look as bad because you have 19 seconds for the transit time to get over to the most remote sprinkler and flow at the proper pressure.
Okay. So when we're doing these calculations, if let's say, what do? They send the design to us. They say, look, can we do, or they can do the transit time themselves. But what are the options then if we've got if we're not getting the 40 or the 20 or what's necessary? How do we modify it? What are the standard modifications that you can suggest to people to get it down to that transit time, aside from obviously putting on the accelerator and taking that time out?
Well, one of the easiest ways to do it is to be able to reduce the pipe size. So it kind of contradicts the hydraulic calculations a bit because you're getting more friction loss as you
Sure.
reduce the pipe size,
Mhm.
but the velocity is increasing inside the piping as you reduce the pipe size.
Okay.
So it's a kind of a fine balance sometimes,
Mhm.
but that is the easiest way to correct it. There's other options like going to smaller systems, like that 15,000 square foot I gave you. That's just kind of a rule of thumb as the maximum.
Yeah.
Certain situations, depending upon the water supply, it could be a smaller system,
Mhm.
and you might even be able to get a larger system if you have a real strong water
Yeah.
supply.
Okay.
So that's just kind of a rule of thumb there. But splitting them up into smaller systems, that could be a possibility. If you have a real large freezer, though, the best time to take that into consideration, that water delivery time,
Mhm.
is before the system's actually being designed, and get the underground to be a loop around the building.
Okay.
And you can have 4 separate points coming in around the freezer
Okay.
to get your systems to be able to meet your water delivery time. Because if you have a gigantic freezer and you put all your manifolds on
Mhm.
one side of the building,
Yeah.
well, you still
The other
might have
side.
too long of a run
Yeah.
out to the farthest system to
makes
be
sense.
able
Yeah.
to meet it. So that's not the easiest approach, but if it's caught early,
Mhm.
that could be a possibility on very large freezers.
Oh, okay. So anything more about the VK598 or anything with these type that they should be, does FM have anything special about it, that NFP13, is there anything special in here that we should be concerned with? Are there times different? Is anybody, or is it just the approvals process that gets us to that, the amount of time that's necessary, or that's required to get
Yeah, so the VK598 is an FM-proof sprinkler, so
Right.
you would be using the water delivery
Right.
times as stated on the
as
technical
stated
data
on, right,
per,
okay,
per the approval of the sprinkler.
per the approval. So you're
Well-
not going to find that 40-second or 20-second in NFPA 13. You're not going to find it necessarily in the documents, but you'll find it as a part of our approval for that particular system.
Yeah, it's also
Or
in
sprinkler.
FM 8-9.
It is in 8-9
Yeah,
as well.
so you can
Okay.
find it there.
Right.
One special things about the 598 though is there's a specific type of system that it can be used on, that can be used in cooler and freezer applications as well.
Oh, do tell.
Fireflex has what's called the BackTech system.
Oh, sure. Yep.
So it comes in double interlock pre-action, so it's perfect for freezer applications. But instead of compressed air going into the piping, it actually draws a negative pressure on it.
Right.
So
Okay.
with it drawing a negative pressure like that, the sprinklers that can be used on it have to be specifically tested along with the system.
Right.
And if you'll notice on the 598 how it has that little T-hinge coming out right
Hey,
here.
well done. You pointed right to it.
How is that little T-hinge that allows, once the sprinkler activates, for it to eject out the side of it and clear the waterway
Right.
instead of coming straight up. So that helps it to be able to work better with that negative pressure that's creating a vacuum in the piping, rather than some other designs where it would operate and eject straight out and could possibly cause a lodgement if it wasn't tested with the system that it's being used on.
All right. So VacTech needs the specially designed sprinklers to operate with it as well.
That's correct. And that is one of the sprinklers that is approved with the VacTech system. One other thing about the VK598 with the VacTech system is, since you have that negative draw of pressure, you're not allowing any moisture to form to help prevent ice plugs. However, for a standard double interlock pre-action system, you do still have to take into consideration and evaluate the air supply that you're using to make sure that whatever air supply you're using, you're not introducing moisture into the freezer or cooler application where you're going to get condensation and eventually ice plugs will develop in the piping on their own without an accidental trip of the system.
Okay.
So one of the better air supplies that you can look at, General Air makes a dry air pack. One of the great things about that in a freezer application is they have dehydrators, automatic dehydrators up on it, and they're continuously drying out the air that's being introduced into the piping.
Okay.
And one's a primary, one's a reserve. So once one becomes saturated, they'll actually switch. And then the one that's the primary now will dry out the other one, so it's ready once you're ready to switch again.
Sure, it keeps going,
So
yeah.
it's just continuously providing dry air
Right.
into the piping.
All right, so the vacuum technology comes with some other provisions in it that either help it work better, or specifically we've got specific sprinklers, the VK598, in a storage warehouse like this that would couple
Yep.
with that very nicely.
Yep.
And provide protection against the ice plugs and the condensation building up.
Yeah, and because of the nature of the FM approval on the
Mhm.
VACTEC system, if you meet certain requirements,
Mhm.
you can actually have a higher C factor, even though it's a double interlock pre-action system.
Is that right?
Yep,
Oh,
that's
okay.
correct.
That helps out in the calcs. Okay, so let's move along then from the refrigerated warehouse to what if we've got a standard warehouse, a heated warehouse, if you will, one that doesn't have a challenge for unheated space, but in that we're going to put a freezer. We're going to put a what was termed, I've heard you say, box in a box. So we'll go with that one. But basically freezer storage. Now, again, the legal definition out here, this isn't an NFPA definition or anything like that. This is a legal definition of what a freezer storage is. And it's anything, as you would imagine, under 32 degrees Fahrenheit. Then they get into also the kind of, that's freezer storage. Now that could be a warehouse, freezer warehouse, or it could be just this box in a box or a walk-in freezer. And this is what we're talking about here, was that when we consider box in a box now. Now, it's a storage, the storage area could be fairly large, right? I mean, these are kind of small, but it could be a much larger box with the warehouse. It could be just a segregated space.
Yep.
That is a freezer. There up above all of that is out in this atmosphere out here in the warehouse, it's all heated so we can have water. We can get quite large, as I said before, in our box in a box spaces here. Now, so this would be kind of the standard way, using what, ELO sprinklers probably to provide protection. We can see that we've got a system with ceiling sprinklers, but then the red piping right there goes down into in-rack sprinklers. So
Right.
Talk us through a little bit about this design, about protecting this freezer within a larger warehouse on a wet pipe system.
Yeah, based upon this example shown here, this would be based upon the commodity and whatever the ceiling height
Sure.
is. This would be showing 2 levels of in-rack sprinklers in the elevation view that we're looking at here. Now, with that, you'd have a double interlock pre-action system, which is what you need, as we discussed, if you have the full height walls. But now we have a heated area up above. So if you come down, for example, like you said, those could be ELO sprinklers. So we have the ELO sprinklers coming down, penetrating through the cooler above, coming off of a wet system. But due to whatever commodity this is and the height of the ceiling, we're requiring 2 levels of in-rack in this scenario, because the ELOs cannot protect with ceiling only protection up to that height. So we still have to go with a double interlock pre-action system to protect the in-rack sprinklers in that application. So we have air supply that's added, additional detection, additional maintenance, just a lot of additional costs that's being added to that application.
Okay. So the solution, or the potential solution then, is to try to get it so that we're eliminating that to ceiling only, or limiting it again, because all of the same, as you said, all the same problems come along with the in-rack sprinklers, from expense to damage to limitations in the flexibility of the movement of the material, or the arrangement of the storage inside, which is always, with the logistics guys and the warehouse guys, something that they hate. They need that flexibility in their cube space. But okay, so now how do we get from there to a ceiling only sprinkler? Because you can't do it with an ELO now, because that design would require in-racks. How do we get to ceiling only? How do we get to this lovely?
You're going to need a larger K factor dry type sprinkler that can provide ceiling only protection up to these higher ceiling heights.
Okay.
So the ELO can only go up to a certain height. It can provide ceiling only protection in certain situations, but it has its limitations as to where you're going to start needing a larger K factor sprinkler to get that ceiling only protection.
Okay, so what are we talking about now? We're talking about
The ESFR dry sprinklers.
The ESFR dry sprinklers. Now, Viking has 3 different ones now. We just added a third.
Yep.
So we're going to talk we're going to spend a little bit of time looking at each one of them, we'll talk about barrel lengths. We'll talk about the temperatures in each of the spaces and how that kind of plays into that. Let's also explore some of the diagrams we have in the data page about how do we segregate or protect that condensation from traveling up the drop and creating ice plugs. So each one of these has a little bit different approach to it, or is it all kind of the same, but just a little bit different distances? Or
yeah, so in 2007, we came out with the first version of our ESFR dry sprinkler, and that was our 14K, the VK502. It was originally called the VK501, so if you ever hear that SIN number, that was the original one.
Okay.
But the VK502 was eventually the 14K ESFR dry sprinkler.
Okay. K502, K14, but it's an ESFR.
It's an ESFR, so one thing you got to keep in mind, even though it's a dry sprinkler, it still can only be installed on wet systems.
Right.
And we get that question a lot because, well, it's a dry sprinkler. Why can't you install it on a dry system? Well, you got to keep in mind, now we're going to these higher ceiling heights, higher commodity classifications with ceiling only protection.
Right.
So you still want to make sure you have the water right there as soon as the sprinkler activates, so that you can start to suppress the fire, because that's what your ESFR sprinkler does.
It's the suppression mode. Now, is that one of the reasons why we have specific barrel lengths now that are associated with this? Like when you order if you're looking at a standard dry pendant sprinkler, with standard spray sprinkler or anything like that for standard operations, you can get them in just about any length, right? It's pretty wide open as far as ordering lengths are concerned, but we actually limit these. There's 4 or 5 different barrel lengths that you can actually order here. And is there a reason for that? Is it just manufacturing, or is there a specific speed reason for it, or anything like that you know of?
Well, as far as the standard dry sprinklers, you can get those excuse me, anywhere from 1/4-inch increments to 1/2-inch increments, depending upon the sprinkler. And you can get them 3.5 inches up to 48.5 inches in certain scenarios per the listing. But what happens once your dry sprinkler starts to get too long, your K factor starts to degrade.
Okay.
So a degrading K factor would mean that if you're getting too much friction loss through the barrel, so you're not getting the proper K factor from that sprinkler anymore.
Okay, because you're not getting the right pressure. Is that because it's related to the friction loss? Suddenly you're not getting it's not performing the same.
Correct.
It's not performing the same.
It's starting to degrade a little bit. For example, if you had an 8K sprinkler and you get too long, it might be a 7.8, at a certain length, 7.6 as you get longer.
Because the barrel itself is all considered part of the sprinkler at this point. It's not like you're adding that into your calculations like you would for just standard pipe in a branch line. That's actually the sprinkler right there at the top. That's at the top of the drop. So we have to take into account all of that. You see them back in R&D all the time, testing the dry drops to make sure we're getting the right K factors out of them. So, okay, so we've got limited K factors because that obviously is going to have an impact on, we want to make sure that it doesn't have an impact on the K factor especially as you get up into these really big sprinklers, they're the big Ks.
And that's one of the reasons. And another reason would be the type of areas they're being installed in.
Mm-hmm.
You know, these are usually more shallow spaces.
Mm-hmm.
You know, you're not a lot of room in between. Whereas with a standard dry sprinkler, there's so many different applications they could be installed in.
Mm-hmm.
So you could have 4-foot long one, you know,
Sure.
going down into the area. Whereas with the dry ESFRs, we know this box in a box type application
Mm-hmm.
is where they're going to be used. And typically you're going to run the lines lower down anyways, even
Mhm.
if you do have a little bit more room up there, like maybe you have a walkway above there, so it might be a little bit higher,
Sure.
but you're still going to run the lines closer down to the freezer.
Okay, so let's talk about the barrel itself. Let's talk about how do we protect from the freezer. We have and each one has these diagrams in it, but we've got a couple of different options now. Sure. For protecting the dry or the barrel from transmitting the cold temperature to condensation up and possibly causing an ice plug at the top. So can you walk us through these, you know, when you might be using or the differences here in the options that we have?
Yeah, we just try to show on our technical data sheets some of the more common types of sealing methods for the cooler freezers.
Okay.
So one method you can see is our insulating boots that, depending upon the sprinkler, you kind of have to take a look at it. Some of them come with it, some of them don't.
Okay.
With the dry ESFRs, on the other hand, you will get both of the insulating boots with the sprinkler.
All right.
So that one, you're definitely getting them, but it's not part of the listing of the sprinkler. So keep that in mind. You don't have to use them. It's a great method for sealing, but in certain applications, you can see there's alternative sealing methods as well. And a lot of times you might want to get a hold of the manufacturer of the freezer.
Oh,
because,
why is that?
Well, they manufacture the freezer, so they know what the best way to seal the penetrations are in most cases to maintain their efficiency rating that they need for that cooler freezer.
Okay. So I see here that in option 3 we've got this, and this changes here. This one right here. Yep. That changes from sprinkler to sprinkler, especially when you get up to the K25. This minimum clearance opening around it. So I'm guessing that's also something that you would be in touch with the manufacturer about, or is that
You're talking about the exposed barrel length on the sprinkler?
No, I'm talking about this one, the minimum clearance into the opening.
Oh, yes. Okay. Yeah. So that's right. As you get the larger K factor, you're going to have to cut a larger hole.
Pipe. Yes, correct. Larger. Yep. And so you're going to also have to have that. So again, here's the other one that I want to talk a little bit about. This is the 6-inch minimum length, and it's measured from here, which is a little different than when we get to the next 2 sprinklers that have the what is that? The grooved groove connection. Groove connection. Yep. So it's measured. This looks like it may be measured in a different location, or is that? Let me show you what I mean here.
Okay.
This is what I want you to see now. That one, it's starting. I guess maybe not, but it's starting right here.
Yeah, that one's a threaded one, so it's a little bit different.
All right, gotcha. All right, so that is a little bit different. Now we're still down to the 2. I'm gonna get back here. We're still around to the same clearance. Now this is the VK504. Yep. This is the 16.8. So this came out a little bit later, obviously after the K14.
Yeah, in order to be able to go even higher, in 2013 we launched the VK504, offering a 17K sprinkler, expanding our ESFR dry line to 17K and 14K. Now, keep in mind with these dry ESFR sprinklers, they have the same design requirements as their standard 14K and 17K ESFR sprinklers.
Okay. So now when you get it, when you get into the design parameters of 8-9 or NFPA 13, they're impacted the same in each location. You got to follow the specific rules. So it's 12 sprinklers, and that's the design. What is that? 3 on 4 branch, 4 on 3 branch lines. But anyway, you're following those particular rules.
Yeah, whatever the
depending on
design
which,
criteria
depending
is.
on the,
Yep.
which job it is, if it's an FM job or an NFPA job.
Yep.
Okay, now let's get into the big daddy that we just launched here with the this particular sprinkler here is the VK512 K25 which takes it up even further, right?
Yeah, the K25, if you go into FM, you could actually get up to a 50-foot ceiling now. NFPA
Right.
stops at 45 feet, but FM, with that criteria in FM 8-9, you could get up to a 50-foot ceiling.
Okay.
And you were talking about design criteria just a minute ago, and you mentioned the 12 sprinkler design.
Right.
Well, FM actually allows you to go up to a 50-foot ceiling and only do a 10 sprinkler calculation.
Yeah, for the
with a
25.
sprinkler.
Yep.
That's correct. Yeah.
So that's a savings that on your FM jobs, and so yeah. Now without getting too crazy with that, but you know something else we've talked about before is the equivalency, and that's something that James Gollenvo and I talked about a little while ago. So the equivalency provisions could actually come back into an NFP. You could submit this for approval to an AHJ on an NFPA 13 job as an equivalency. Same rules apply. It's nothing different about this than there is about, you know, the 9 sprinkler design or the 10 sprinkler design with the K28 that we've talked about in the past.
That's correct.
Past episodes. So, all right. So again, anything particularly special about this other than it can go way up high now? Is it, you know, anything else you want to talk about here?
Yeah, you want to go back to the 17K a second here? I just kind of want to show a difference.
Which one?
It's a little bit hard to see here, but the 17K on the inlet, on the grooved inlet, we always say that you cannot put you cannot put dry sprinklers on an elbow, and that's always been the rule of thumb in every situation.
Sure.
But the thing is, with the design of the 17K and the design of the 25K, the groove actually, since you're on a wet system, you're in a heated area, you could actually connect it to an elbow because the grooved inlet does not penetrate up into the waterway. So it won't bottom out like your standard dry sprinklers would or some other designs would, you know, where it actually goes up into the waterway. Because it doesn't need to, because it's on a wet system in a heated area.
Yep.
So the VK512 does have that as well, the 25K factor. And I just wanted to point that out with the 17K also. Another thing about the 512, we're only offering it in a groove version. So in the past, the 14K and the 17K, we offered both in thread and groove. But we just from the feedback we've received, it a lot more customers like the groove connection when they're installing it, you know, in the box-in-a-box type application.
Okay. And so it also gets in, we also get specific to, here's the change there as we get into the larger, diameter piping that for the K25 that we actually wind up with a minimum clearance that's, what's that, 3.5 or 3.25?
Yeah, and it's actually, it's not the barrel itself, because on the K25, that's only an 1.5-inch connection.
Okay.
It's actually, if you look at the sprinkler frame and the inlet, depending upon how you're installing it, that's what needs the clearance.
Is it? Okay.
Yep.
All right, that's interesting right there. It needs the greater clearance. Okay. But we also get into, with this one, we also highlight, and with all of them actually, we actually highlight the minimum exposed barrel length. So we talked about that, where it starts, how you measure it, what the minimums are. And what's important here is that this is actually driven, this particular one is driven off of, is the NFPA 13 requirements.
Correct.
Okay. Yep. So, and they take it from 40 to 50 to 60 degrees out, you know, out in the greater warehouse, out where the piping is, the water piping, the water filled piping is. And then they take it over to that one here, this column right here gets into the, what the ambient temperature is within the freezer, within that cooler space. And that's how they govern what the minimum barrel distance, minimum barrel length is. Now, FM doesn't do that. They have just a minimum done and dusted, right? How is that? What is that set up?
Yeah, based upon the current edition of FM 8-9, if you look at it, there's a section in there that references the minimum exposed barrel length, and it says that a 12-inch minimum exposed barrel length
Mhm.
shall be used. I forget the exact language, but it is 12-inch minimum in
Okay.
this section. Where, yeah, in NFPA 13, you have your table where you have to take into consideration the ambient temperature in the heated area, the ambient temperature in the non-heated area,
Mhm.
and go to this chart in order to make that determination.
Yeah.
And we are publishing these charts now on our data sheet as well,
Mhm.
so that the customer has that right at their fingertips.
Okay. So obviously you can find all of this information on our data pages and also going to the sprinkler selector on our website. That basically covers everything we wanted to talk about here today. We wanted to discuss the various types of cold storage, describe the systems that are used to protect them and the sprinklers that are used on those systems. Is there anything we've missed so far? Is there anything we've missed at all in this that you want to add on?
I believe we've covered all the bases. That's for what we wanted to go over for cold storage applications at this point in time.
All right. So if you have any questions or if you need more information, you can get a hold of Shaun and his team over at Tech Services there at that email. Any information you need on training, and we have an extensive portfolio of training seminars, including all the Tech Talks that we've produced at the www.vikinggroupinc.com/training, and visit our customer learning portal, set up a username and password, and you can get in access to all of the Viking training. Or if you've got a question on upcoming seminars, upcoming schedule, where we're going to be, training at vikingcorp.com is the place to go. So thanks for your time and attention. I'm Jim Lake. This is Shaun Kramer for Tech Talks. We will not be having another, we'll be skipping the month of August, taking the month of August off. We got a busy month there, but still taking it off from Tech Talks. The next Tech Talk will be in September. We're going to still pick a date, but keep an eye out from email from our marketing department, from Taylor. She'll be sending emails out, letting you know exactly when that's going to be and what the topic's going to be. So thanks for your time and attention, everyone. Have a good rest of your summer.